Hello everyone, this is lab number 3, DC circuit. The objective of this lab is to study the DC circuit by using Ohm's law and the RC circuit by observing the fall of the voltage. So first of all, I would like to introduce you what is DC circuit. DC circuit means direct current circuit. Okay, direct current circuit. We have DC circuit, and we also have another one called AC circuit. For AC circuit, the electricity from the electrical outlet, 220 volt, that is the alternating current. So keep going. Of course, you're quite familiar with Ohm's law. Then next one is RC circuit. What is RC circuit? R means resistor. The resistor we use in the last lab 2. Then we have a new one, which is capacitor. You'll see it in this lab. So RC means resistor and capacitor circuit. The simplest circuit of RC circuit should consist of at least one resistor and one capacitor. Then in this lab, we will, based on the simplest RC circuit, then observe the fall of the voltage. Next one, keep going, we go to the theory. Ohm's law is written as V equal to I times R. Again, here. Then where V, voltage, I, current, R, resistance. After that, so we come to the RC circuit. So I show you the graph. Graph A is a RC circuit. For the RC circuit shown in figure 1A, after the switch has been closed for a long time, the capacitor has been fully charged. So when we close the switch, then this circuit is connected, then the current flow in this direction, then give the capacitor, charge the capacitor. Then the switch is opened. After that, we open the switch. The capacitor discharges its current through the resistor of the multimeter. So after that, when we open the switch, there will be another circuit. This capacitor has been charged. Then they will go to this circuit with the we give a R meter, we give a voltmeter parallel with the old circuit. Then after we open the switch, the capacitor will becomes to be a power supply, or like a battery, to make a new circuit with R meter. Then after that, the voltage across the capacitor changes and falls as a function of time, defined as this function. In this function, VC it means the voltage on capacitor here. V means the total voltage we give from the power supply, from the battery. Then R. So we have this form. One is R, one is C. So R is, we call meter resistance. When we parallel a multimeter on it, in a multimeter, especially for the voltage meter, there's a very large resistance in the multimeter. So R is the meter resistance, C is the capacitance. Then these two times together is a constant tau. So tau equals to R times C. There is a relation which is, when we plot Vc and T, the voltage graph is exponential decay. So at the time tau equals to RC, this time, the timing will get 0.37 V, 37% of the starting value V. That is the theory part. So now we come to experiment part. I will introduce what we are going to do in this lab to you. First part, study Ohm's law by measuring voltage and current of the DC circuit below. Number 1, we have A, which is a simple circuit, B, series circuit, C, parallel circuit. Okay, we have these three circuits, and we're going to measure several things. Here's a table. Okay, for 2A, 2B, 2C, we need to measure this kind of thing. For 2A, we need to measure VBA, I total, R total. For 2B, 2C, we have several data to measure. After that, we go to do a lot of measurements. Then you need to read in the video. Then you need to use Ohm's law to calculate R1. Then compare with the reading code, the color code. Then calculate R2, also compare with the color code. Calculate I1 from measured value, I2 from measured value. Keep going, we come to the most important part in this lab, and this is the R circuit. Study R circuit by measuring the voltage across the capacitor at various times. Then plot ln Vc, the function, and with t. Finally, determine the Rc time constant from the graph. So what we are going to do is that to prove that this, in the theory part, we have this plot, right? Then here is t. When t equals to tau equal to Rc, at the Rc time, we will get 0.37 volt. This is the starting voltage value. Then so first of all, we have three values: V, starting voltage value; C, capacitance; R meter. Then come to a very big table. When you go to watch the video, then you will know what this table used for. So there's a voltage meter. Then we have a stopwatch. Then you read the multimeter every 10 seconds. So there's a multimeter. Then you go to read for 10 seconds, 20 second, 30 second, and you get the first time value data you collect, and keep going on. After that, you get second time again, do it again. Watch that 240 second video the first time, then reverse the video to read the 240 second video again to be the second time data taking. After that, you have 2 times data, then do the average. You got V bar, right? This is the average voltage. Just plus the 2 times voltage, then divided by 2. After that, all the data has been measured. Next step is to plot. Okay, as what we see here, plot a graph which is ln and t, ln VC and t. Okay, that's the theory part. Thank you.